Okay, in this lesson we are going to look at an introduction to chemical reactions. So far we've been looking at chemical nomenclature, the words to the sentences of which chemical reactions are. So a chemical reaction is a process in which one or more substances changes into one or more new substances. So for example, hydrogen gas reacts with oxygen gas to yield liquid dihydrogen monoxide, I should say. Dihydrogen monoxide. So to create a word equation from that, we would write hydrogen gas plus oxygen gas yields dihydrogen monoxide. Dihydrogen monoxide plus 572 kilojoules of energy. So this is energy that's released because it's on the right side of the equation. This shows that this is an exothermic reaction. Exo meaning exit, so the heat is exiting or released. That's how I remember it. The opposite of exothermic is endothermic. So if the energy is on the reactant side, it would be endothermic, requiring energy. Endothermic needs energy. For example, you would could think about photosynthesis, right? We learned that before, where you have carbon dioxide plus water plus the sun's energy, or sometimes you would put the sun's energy on the arrow. Okay, so that energy shows that the reaction is endothermic. So a couple more things about this reaction. Just the little plus means reacts with, and the arrow means to yield. Okay, so to make a skeleton equation from this, we would take the words and make them into symbols. So hydrogen gas is H2 as a gas plus O2 as a gas. The arrow is the same. H2O is a liquid plus 572 kilojoules. That doesn't change. And the last step in this would be to make this into a balanced chemical equation. So that will be happening later in the lesson. I'll show you how to do that. But in essence, we are making the number of entities on the left side equal to the number of entities on the right side. So if we look at, for example, this one here, the skeleton equation, we have 2 hydrogens on the left, we have 2 hydrogens on the right. So that looks good, but then we have 2 oxygens on the left and 1 on the right. So in order to make that balanced out, we would have to put a 2 in the front, which is what we did. So now there are 2 and 2. This changes the number of hydrogens to 2 as well. Sorry, to 4. So we had to make this 4 by putting a 2 in front as a coefficient. So note, in a chemical reaction, there are no atoms lost, created, or destroyed. The total mass of the reactants equals the total mass of the products, and the total energy of the reactants equals the total energy of the products. And how do we know this? Well, the law of conservation of mass tells us that the total mass of the reactants equals the total mass of the products. Oops, I should read products, it's missing a T. So what's some information conveyed by a chemical reaction? So we have the starting materials. So we see that H2 and O2 are reactants. the products. H2O is the product. If we have any special conditions, which we do, a spark needs to be present in order for hydrogen and oxygen gas to react. We also see the molecular ratio. So it tells us that 2 molecules of H2 react with 1 molecule of O2 to make 2 molecules of water. The states of matter: gas is G, liquid is L, aqueous is AQ, and solid is S. Okay? Energy, as I mentioned already, shows us that if it's on the right side, it's releasing energy as and it's an exothermic reaction. If it's on the left side, it needs or absorbs energy, and it's endothermic. Okay, so where does this energy come from? Well, molecules possess energy, right? They possess kinetic energy, and this is because they're moving. So they have vibrational, translational, and rotational motions. And they also contain potential energy stored in chemical bonds because of the forces of attraction between atoms. If a bond is broken during a chemical reaction, energy is needed to break a bond. Again, that's endothermic. And if a bond is created during a chemical reaction, energy is released. Usually there's a combination of both of them, and this will determine if it's exo or endothermic overall. Oops, that should be these 2 factors. I highlighted the wrong thing here. So these 2 factors determine if a reaction is endothermic or exothermic. Some chemical reactions require the presence of a catalyst for the reaction to take place. And a catalyst is a substance that makes a chemical reaction occur faster without itself being consumed in the reaction. So for example, hydrogen peroxide decomposes in the presence of manganese 4 oxide, also known as manganese dioxide as well, to produce water and oxygen gas. So the manganese dioxide is not used up, or produced, neither is it a reactant or product. Okay, so it's just there to help the reaction take place. How do we recognize a chemical reaction has happened? Well, there's a few clues that we have, and one of them is a change in energy, and that would be heat or light given off. So for example, if you put hydrochloric acid and sodium hydroxide together, you produce salt, water, and energy. It's an exothermic reaction. Heat's given off. Sometimes there's an evolution of a gas. So in the example of zinc is added to hydrochloric acid, you get zinc chloride and you get a gas produced, hydrogen gas. And sometimes there's a formation of a precipitate. This is a solid that forms in a liquid. So lead to chloride plus potassium iodide produces a bright yellow color of, in solution, you have lead to iodide, and potassium chloride would be in the solution, so it becomes bright yellow. So this is a color change. So this color change can happen in many reactions, and in this one here, we have copper 2-sulfate pentahydrate. Oops, this blue should be, starts out as blue. Okay, this actually, this color. So it starts out blue, and then once you heat it, it becomes white. Okay, so it will turn white with time. So that's a color change and a clue that a chemical reaction has happened. Also, an odor can be released again. So this would happen oftentimes when a gas is released. So if you put iron sulfide and hydrochloric acid, you produce iron 2 chloride and hydrogen gas. And it smells like rotten eggs. Believe me, you don't want to smell that one. Okay, so now that we know about that, we can talk about how we balance chemical equations. So we balance chemical equation to give the ratio in which the chemicals react. This is done through coefficients placed before each chemical. So we saw this reaction already. Hydrogen peroxide produces water, oxygen, and energy. So in the chemical equation, this is H2O2 produces H2O and O2. So it's not balanced yet. Why? Well, let's take a look. We're going to count what we have as reactants and as products. So we take inventory of our oxygens and our hydrogens, because that's all we have here. So we have on the left side, we have 2 oxygens. On the right, we have 1, 2, 3. Hydrogens, we have 2. And on the right, we have 2. So we see there's an imbalance of oxygens. So how can I change this? Well, we often would double things or triple them to see what will happen to the numbers. So in this case, we'll double it because that'll give us 4. So that gives us something achievable on this side. So we'll make this a 4. So that means we have to put a coefficient in front. So that changes my oxygens to 4 and my hydrogens to 4. So we then see that we have to change on this side as well. We need to have 4 hydrogens because we have 4 on the left side. And we don't have enough oxygens either. So what can we do to change that? Well, let's try to make this into a 4. So if we have 2 here and 1 here, if I put a 2 in front, that means I now have 4. It also changes my hydrogens to 4. So I'm done. It's balanced. So that's how balancing works. So when you have the total number of atoms of each type and the reactants the same as the products. So there's a few rules or guidelines on how to do this. So the first thing you have to do is start by writing a skeleton equation, which is what we saw above. So the chemical formulas are included without any coefficients. We balance atoms that appear only once on each side of the equation by placing appropriate coefficients in front of the chemical formulas. So you would balance everything but oxygen and hydrogen as a rule, because once you have balanced everything else, those other 2 will be balanced out. Leave atoms that appear more than once to the end. Treat polyatomic ions as one unit rather than as individual atoms, providing that they do not change during the reaction. So they have to be the exact same on both sides of the equation. Okay, and check that the final equation is balanced. Okay, so let's try an example here. First, we have to write the balanced chemical equation for the reaction of sodium and oxygen to produce sodium oxide. So we're told everything here. We've got sodium and oxygen to produce sodium oxide. So we have sodium Na plus O2 to produce Na2O. This is why we learned nomenclature prior to this lesson. So we count our sodiums, count our oxygens. We have 1 on the left side and 2 on the right. And oxygens, we've got 2 on the left side and 1 on the right. So we'll go to where we have to make the change for sodium. This has to be a 2, so we balance that by putting a 2 in front. It is now balanced. How can we balance the right side? Well, we've got 2 on the left and 1 over here. So we're going to put a 2 in front of this, but now that's going to change our sodiums too. Our oxygens became a 2, and our sodiums are now 4. So we can quickly go back to the reactant side and just make that a 4, and that makes that a 4. And then all is well. Okay, so we finished balancing that first one. Let's try another example. Write the balanced chemical equation for the reaction of copper and silver nitrate to produce copper 2 nitrate and silver. So copper and silver nitrate to produce copper 2 nitrate, NO3, plus silver. So we'll count copper, silver, and here's one with a polyatomic. We'll put nitrate all together. Just makes it easier than breaking it up into nitrogen and oxygen. So we've got 1 copper on the left, 1 copper on the right, 1 silver on the left, silver on the right, 1 nitrate on the left, and 2 nitrates on the right. So all good, all good. Oh, we gotta make a change here. We need 2 nitrates on the reactant side, so we'll put a 2 in front of the silver nitrate. That changes that to a 2, and our nitrates to a 2. So we'll just go back to the product side to put a 2 in front of the silver to make that a 2. And that is it. Okay, so that is it for the lesson. So you have some word equations to write and balancing equations, so you can work on the questions in your package. Have a good night.